Hello students, welcome to physics classroom. I am Vaibhav, your physics teacher. So today we will discuss about the unit vectors. Okay, there are different types of vectors. First of all, we will discuss unit vector. Then we will discuss the Cartesian form of vector. Okay, then we will go so on. Right. The first of all, we will discuss about the unit vector. But what is unit vector? In the last class, we have discussed the vector, right? Okay, so how can we add the vector? The different laws to addition the vector. Okay, the first of all, means the vector is a magnitude as well as direction. Okay, means if you have a specific magnitude, but how can we define with the specific direction? So if we get the one direction, then we can multiply with this unit vector with the magnitude, then we will get a complete vector. Okay, means you can say if I take there is a one x axis and this is y axis. Alright. If the vector is moving from origin towards the x axis. Alright. So if I take the magnitude of a vector A is 5. Alright. It's the 5. But how can we get the direction? How can we represent the direction of a unit vector? Okay, in the x-axis, so we will get there's one simple formula. The unit vector is represented with the any alphabet, okay, with a cap on this. Okay, this is the representation of a unit vector. Okay, and how can we get the unit vector then? So we can easily use means vector A divided by, okay, means this is a vector A. There is a magnitude 5. Okay, so if I divide with the magnitude, so there is only one unit of this vector. Okay, means if I divide the magnitude of vector A, so we will get a unit vector. For example, if the vector A is 5 Newton or anything, okay, the 5 unit in north direction. Just like that. Okay, so what is the unit vector then? So it will be A vector divided by magnitude of A, means 5 divided by magnitude of vector is 5 in the north direction. So the unit vector will be 1 in north direction. This is the unit vector. Okay, so we can represent the such type of unit vector in a different axis. Okay, just like that. In the x-axis, for means if we get the unit vector on the x-axis, the unit vector represent with I cap. Okay, on the y-axis, the unit vector represents on j cap. Okay, and on the z-axis, unit vector represents with k cap. Right, just like that. So these are the unit vectors we can represent with I cap, j cap, and k cap. Why I'm writing like that? Because we have to define or we have to represent these vectors in the Cartesian form also. Okay, Cartesian form means on the axis A axis, Y axis, and Z axis. Alright. For example, if I take the representation of unit vector or the representation of a vector in Cartesian form, right? You all know the number line, right? So what is number line? Okay, this is x-axis, this is y-axis, like that. Okay, so these values from the origin in the right side is positive, in the upward on the y-axis it will be positive, in the downward negative, on the x-axis in the down left side, okay, it will be negative, as like that. Okay, so if I take the one vector a vector is just like that. Okay, now I am forming, okay, so I am drawing the parallel lines from the head of the vector A, which is parallel to y-axis and parallel to x-axis. Just like that. Okay, is the line parallel to y-axis, and this is the line parallel to x-axis. So what we get? We will get the components, or we will get the magnitude of a vector on x-axis. Alright? Okay. This is the magnitude of the vector on x-axis. This one. Alright? And this is the magnitude of vector A on y-axis. Alright. So we can represent this A vector on the magnitude of vector A and on x-axis and y-axis, or we can segregating the components on x-axis and y-axis. Okay, so how can we write the vector A? We can represent with magnitude of vector A on x-axis with unit vector on x-axis, which is represented with I. Yep. Okay, then plus the magnitude of y-axis, okay, on y-axis of a vector A with a unit vector on y-axis is j cap. Accepted? Okay. Let's remember this thing. In the last class, we have discussed the triangle law of addition. Okay, means so this is the axi cap. This is ayj cap. Okay, this is the one vector, this is another vector. So this vector A will be the summation of axi cap plus ayj cap. Right. Okay. So if I move this line toward this, so we will get the representation resultant vector. Okay. It's like, okay. Now we will discuss how to represent the vector in the space. Okay. So the next topic is the representation of vector in space. Okay, so like that I am drawing the one box. Okay, just like so. This is the x-axis. This is y-axis, and this is z-axis. Okay. If I am drawing from the origin, there is the one vector. Okay. Okay. This is the vector right? Just like that. So how can we represent? So this is the value. Okay, so this will be the value of x-axis or the component on the x-axis. Okay, so the component on x-axis, right? This is the component on y-axis and is the component on z-axis. Right. We already know. So how can we represent the unit vector on the z-axis with the help of a k cap? Right. So how can we represent that? The r cap. We can use r only here because we are using r vector, right? Right. So the rx I cap plus ry j cap plus r z k cap. Just like that, we can represent the vector in a space with the help of a three axis on the component on the different axes. Alright. Then another, with the help of this diagram, we can find what is the position vector. Right. So I am giving some name like that. See here. Alright. So I am giving this is the O, A, B, C, D, E, F, this is G. Okay. And this value will be 2 unit, or we can give 6 unit, 4 unit, and this is 3. Or we can give the components or the coordinates 6, 0, 0. This will be 0, 4, 0, and this will be 0, 0, 3. So, what is the definition of a position vector? Okay, means the vector attaching from origin to desired point. Alright. So here I am writing the G vector, okay, or the position vector of G. Okay, so the G vector will be component on x-axis, this is 6 I cap, plus component on y-axis is 4 j cap, plus component on z-axis is 3 j cap. Just like that. Okay, so this is the position vector. Right. Now we will discuss about the how can we give the components. Okay. Components of vector. Okay, so we can use the one specific word is the rectangular component also. Right. So how can we find? So if I take the any vector, just like that. Okay, I am taking the A vector. Okay, but this A vector is making some angle with x-axis, right? Theta. Okay. So if I make the one triangle, so rectangle, okay, just like that. So the components of a vector means this a vector will be the resultant of the components of a vectors. Okay. So this is the summation or the addition of both vectors. Okay. It will be, this is the ax and this is the ay. Okay. But how can we represent in the form of theta? Okay. So this will be, if I take, you all know sine theta. Okay, the sine theta means opposite side upon hypotenuse. Okay, so this will be the, if I take this triangle, okay, this is the opposite side and the a vector is nothing but a hypotenuse. Okay, means a y by a. Okay, and the cos theta means adjacent side upon hypotenuse. What is the adjacent side of a angle theta? Okay, ax divided by a, divided by a. From here we will get ay component will be a sin theta and ax component will be a cos theta. Okay, with the help of this we can represent here the a vector will be a cos theta I cap plus a sin theta j cap. Okay, in this way we can find, okay, we can find the components of vector and we can write in a Cartesian form also. Okay, we can write in the form of Cartesian form also. Okay, now here, if we get the two vectors with the two components, okay, if we get the two vectors in the Cartesian form, okay, we can give the addition of vectors in Cartesian form. So how can we add these two vectors? If I take the vector A, right, then if I take, there is another vector, vector B. Okay, so the resultant vector, it will be start from tail of vector A and it will be up to the head of vector. So how can we calculate, okay, the addition of vector A? You all know this vector A is vector A plus vector B. This resultant vector will be the addition of vector A and B. Okay, but again here also we can divide into the components. So how can we divide? I take, this is the y-axis, the x-axis. Alright. So here we all know this c vector is nothing but cx on the x-axis plus of I cap plus cy of j cap. Alright. Then a vector will be ax I cap plus ay j cap. Alright. And b vector will be by dx I cap plus by j cap. So how can we represent? So this is the Cx, this is Cy. Okay, but here this is Ax and this is Ay. Correct. And again here this is Bx and this is By. Right. Now you can easily find out, okay, the Cx is the addition of Ax plus Bx. Okay. And the Cy will be the addition of Ay and By. Alright. So if I write here, the Cx will be the Ax plus Bx and Cy will be the Ay plus By. If I putting these values Cx and Cy here, okay, so what is the solution? This C vector will be the Ax plus Bx of I cap plus Ay plus By of J cap. Okay, this is the addition of two vectors we can easily add. So what are the components on the x-axis and the y-axis? Or with the I cap and j cap, we can directly add ax plus bx, I cap plus ay plus by, j cap. Okay. For example, we can take one example also. Okay. If I take this a cap is 3 I cap plus 4 j cap and the b cap is 4 I cap minus 8 j cap. So what is the addition? The C cap is A cap plus B cap. This is the summation. Okay. The resultant vector will be 3 plus 4 I cap plus 4 minus 8 j cap. The C vector will be 7 I cap minus 4 j cap. Just like that, we can add these vectors in the Cartesian form also. Alright. Okay. Then how can we find the magnitude? Okay. So how can we find magnitude? We will discuss these also. Again I am drawing the one cube so we can easily understand. Isn't that? Okay. This is the origin. Alright. A, B, C, D, E, F, and the point. So now again I am drawing the one vector which is starting from O and okay. Now you can see here. Okay. So this should be the here only you can do. Okay. This OG. Okay. This O, first of all, the magnitude of vector in Cartesian. Right. Here the OG square, you all know the Pythagoras theorem. Right. Okay. This OG square will be See here, if I taking the one line on this plane BOD and C. Okay, this OG square will be the OC square plus GC square. OC square plus GC square. Alright. And how can we find the OC square? Right. OC square will be the OB square plus BC square. OB square plus BC square. Okay. Now you can know, right? This BC is nothing but x component. Right. If I am taking this A, this will be a x component. Alright, then OB is a y component. Okay, and the GC is z component. If I put this value here, so the OG square will be OB square plus BC square plus GC square. If I am putting these all three values here only, so we will get A square, okay, or we will get, this will be AX square plus AY square plus A Z square. This is the square, right? So we will use this magnitude or square root. This is the magnitude of vector A. Okay, this is the magnitude of vector A. Okay, so till this, if you understood, so we will discuss in the next class the multiplication of vectors. There is a two types of vectors. Okay, two types of multiplication of vectors: the cross product and dot product. We will discuss this. Then we will discuss the trigonometric ratios in the upcoming classes. Okay. So if you have any doubt, so you can write in the comment section. Okay. So I will give all these details, all these notes in the description box. You will get a one Google Drive link. Okay, on that only I will upload the some questions also for practicing at your home. So till the next class, stay tuned. Please like, share and subscribe. Thank you so much.